Hi there, everybody. So yesterday in class we had a refresher course on the Pythagorean theorem and right angle triangle trigonometry. We learned how to find missing sides using the Pythagorean theorem and to find missing sides using right angle trigonometry. And today we're going to talk about how to find missing angles using right angle trigonometry. So let's go ahead and take a look at how we can use trig to find missing angles. In order to find missing angles, we are going to need to use some inverse trigonometry, and it looks like this. The inverse of sine is written as sine, and it looks like it says to the -1 power. That's not actually an exponent, it's just a notation for inverse. So that's the inverse sine, the inverse cosine, and the inverse tangent. They're also called arc sine, arc cosine, and arc tangent, which means when you type them in the calculator, your calculator might put the letter A in front of them, and that is correct. That means the inverse. So that is okay if that happens. So the inverse trig will undo any trigonometry operations that are happening, and we're going to have to do that in order to solve for angles. One more note to write down is that this symbol is going to show up, this O with a line through it. That is called a theta. A theta is a Greek letter T, and it stands for a missing angle, often used in mathematics to notate missing angles. So let's go ahead and take a look at our first example. Our first example here, we have this right triangle. You can see the 90-degree angle in the bottom right-hand corner. Theta is the upper angle. We have a base measurement of 11.92 and a side measurement of 10, and we don't know what the hypotenuse of this triangle is. And our job is going to be to find theta. Now, in order to figure out how to find theta, I'm going to need to figure out which trigonometry operation to use, and I won't know which one to use until I figure out what information has been given to me. So, using theta as my reference angle, I'm going to go ahead and label the three sides of my triangle based on their position. The easiest one, of course, is to label the hypotenuse because it won't change. The hypotenuse is the longest side opposite the right angle, which is this side right here, the hypotenuse. Now that we've labeled the hypotenuse, let's go ahead and take a look at my reference angle. If I take this symbol for the angle and turn it into a little pupil, I can see that this angle is looking toward the value 11.92. So that is my opposite side. That is what I'm looking at. And last but not least, the only side I have left over is the adjacent side. But we can also see how it makes the right leg of an A shape. So the adjacent side makes the side of my A value, A shape that is not the hypotenuse. So 10 is going to be my adjacent side. Now that I have those three values, let's go ahead and take a look at which ones are most important to my problem. And I can see that they've given me the value for my opposite side, O, and they've given me the value for my adjacent side, A. So those two values must be very important to my problem, which means I need to relate those back to the three trig functions, sine, cosine, and tangent, using SOH, CA, TOA. So the only trig function that uses both O and A is the tangent function. So I'm going to have to make a tangent problem in order to solve this. So our tangent is going to be of an angle, and in this case my angle is theta, and I don't know what it is yet. But my tangent, TOA, tells me that it is the opposite, which here is 11.92, divided by the adjacent. And the adjacent in this case is the number 10. So the tangent of theta is going to give me the number 11.92 over 10. The problem is I need theta by itself, which means I need to undo the tangent function, and that's when we're going to go ahead and use the inverse tangent function to do that. So I'm going to do the inverse tangent on both sides, and it is applied on the left-hand side. Just like tangent is to the left of the word theta, I'm going to go ahead and say that this is my whole input, and I'm going to take the inverse tangent of the tangent of theta. And over here, same thing, I'm going to take the inverse tangent. I'm only writing it underneath because I'm running out of space side to side. Inverse tangent of 11.92 over 10. So I'm applying the same inverse on both sides of this equation. Now what's going to happen on the left is my inverse tangent and my regular tangent are going to cancel each other out. And the only thing I'll have on the left-hand side is just the symbol theta. On the right-hand side, however, I'm still going to have the inverse tangent of what I had before, 11.92 over 10. And all I have to do to get my final answer is type the inverse tangent of 11.92 over 10 into my calculator. So let's go ahead and see if I can pull up my scientific calculator from my computer here. There it is. So this is the scientific calculator that your computer gives you. And we have the scientific calculators in class, obviously. So for the one that the computer gives you, I want to show you how you can type this in. So we want to go ahead and type in the inverse tangent. You'll notice I do have a tangent button here, but it's just a regular tangent. It's not an inverse tangent. So in order to get the inverse tangent, you'll notice there's this tiny little up arrow at the very bottom of the tangent button. In fact, all of the ones in the top two rows have tiny up arrows. And that means that if you hit this up arrow, it will give you alternate functions for those. So you'll notice if I have it unselected, it's just tangent. But as soon as I push the up arrow, it shows me the inverse tangent. So that's the button I'm going to have to use. You'll notice also on this calculator on the computer, I have to type the input first and then apply the tangent value. It doesn't let me do it in the opposite order. So I had nothing plugged in, so now it's trying to find me the inverse tangent of 0. So what we're going to have to do is start over, and we're going to have to type in the input first, which is going to be 11.92 divided by 10. That's our input. I'll hit equals. And now I'm going to find the inverse tangent of that button. So make sure the up arrow is selected, hit inverse tangent, and then hit equals. It tells me that my inverse tangent, oops, that's not right. Sorry, let me try that one more time. 11.92 divided by 10 equals inverse tangent. Oh, I guess I don't have to hit equals. I'm sorry about that. So I hit inverse tangent, and it automatically tells me what the solution is. And the solution is 50.0058. So we're going to go ahead and round that to 3 decimal places, 50.006. And let's type that in here. Theta equals 50.006. What I had done last time is hit enter again, and then it raised it to another tangent, and it gave me a different answer. So we want to make sure that the first answer it gives you is the one that you write down for your solution. Okay, so we found theta equals 50.006, almost exactly 50 degrees here, and that problem is completely finished. Let's go ahead and take a look at doing that again. Here is another triangle. This is a right angle again. We have a hypotenuse this time of 9 and a base value of 6. I don't know what the other leg is. And we're trying to find the theta value between the 9 and these 6. And in order to figure out what my theta value is, I'm going to have to start by figuring out what lengths I have been provided. So let's start labeling the sides of this triangle, beginning with the hypotenuse again. So this one over here, the longest side, the one opposite the right angle, is the hypotenuse. And then if we go ahead and take a look at our angle theta, the one opposite theta is this guy over here. This is the opposite side. I don't have any information about it. And last but not least, if I make this into an A, it's on its side. One side is the hypotenuse, the other side is the adjacent. It's also the only side left. So let's take a look at the critical information we have here. 9 is the hypotenuse, so we have H, and 6 is the adjacent, we have A. And let's go ahead and take a look at what we can do with those. We have SO, CA, and TOA, and the only operation that uses both A and H is the cosine. So our formula is going to have the cosine of our angle, and our angle this time is again theta. I don't know what it is, but I know it's going to equal AH, so A over H. So it's going to be the value 6, the adjacent, over the hypotenuse, which is 9. So the cosine of theta is going to be 6 over 9. You can simplify that fraction if you want to. We don't necessarily need to. We'll get the same answer in the calculator because we still have to undo that cosine operation in order to solve this problem. So the cosine of theta is going to be 6 over 9. So in order to get theta by itself, I'm going to take both sides of the equation and I'm going to apply the inverse cosine to both sides. I'm going to undo that cosine operation. And I'm going to do it to both sides because that's how we keep our equation balanced. On the left, my inverse cosine and cosine will cancel, and theta will be alone. And on the right, I'm going to have the inverse cosine of 6 over 9. And that is the information that I'm going to have to plug into my calculator. So let's go ahead and take another look at the calculator and see about plugging that in. So the scientific calculator on your computer, we've learned that you have to type in your input first. Our input is 6 over 9. There's our input right there. Now we have to apply the inverse cosine, so I'm going to make sure that my up arrow is selected. So I see inverse cosine, cosine to the negative 1 power. I'll hit that button, and it automatically gives me my solution. So theta is going to be 48.1896. That 6 will round up, and it will make the 9 round up as well. So what you can do, and let's take a look at this, 48.1896. 1896. What you can do when you have two things that round up at the same time is, instead of just looking at this one to see how it rounds, I look at these two values as their own number. So this is 896. It's going to round up to a 0 in this decimal place, which is going to make the whole thing round up to a 90. So from 89, it will round up to a 90. So my final answer for theta is 48.190. All right, so that's it for that example. We have one last example to do. Let's go ahead and take a look one last time at finding missing theta. And I would like it if you would write down this problem and then pause the video and try this on your own to see if you can get the same answer that I'm going to get. Once you're finished solving this on your own, please resume the video and see if you got the right answer. So go ahead and pause your video now, please. Okay. So if you paused the video and worked on this on your own, I'm super duper proud of you. If you didn't, shame on you. And let's go ahead and take a look at what you got. All right, so we have a right triangle here, right angle in the bottom right corner, theta in the bottom left. We've been given the hypotenuse right off the bat. I can label this side as the hypotenuse. It is the longest side and it's opposite the right angle. And now looking at theta, here, there's my little eyeball. I can look this way, and the opposite side that I'm looking at is the value 3 right there. And for the adjacent, this is the other side of my hypotenuse. Here's the other side of my sideways A right there. So this is the adjacent over here. We have all three sides labeled. Let's see which ones we care about. We have the value for the hypotenuse. We have the value for the opposite. And that's it. So if we look at SOHCAHTOA, the only one with O and H together is sine. So let's go ahead and look at using sine of our angle. I don't know the angle yet, sine of theta, equals OH, O over H. So the opposite, 3 over the hypotenuse, which is 5. And we've learned now that in order to undo sine, we have to use the inverse. So I'm going to do the inverse sine on the left, and I'm going to do the inverse sine on the right to keep everything equal. I'll do the same thing to both sides. My sines will cancel on the left, and I will have theta equals. And on the right, I will have to type in the inverse sine of 3 over 5. Let's go ahead and take a look at plugging that into the calculator. So here's my calculator. Let's go ahead and type in our fraction first, 3 over 5. There we go. And then let's go ahead and type in our inverse sine to perform on this number. So let's make sure we have the up arrow selected. On your calculator at school, this would be the second button. That's what it does. It shows the second function for each button. So sine inverse is the one we're going to select now. And it looks like the answer there is 36.8698. So let's see how that rounds. Theta equals 36.8698. And again, our rounding is going to do something fun here. So when we round this, the 8 will round up, and this 9 will round up as well. So we'll look at the entire 2-digit number, and 69 will round up to 70. So our final theta answer is 36.870. And that's our final solution for this problem. I hope that you tried that on your own and you got the answer correct. At this point, I'd like you to please start on the 2 classwork questions on Canvas.